Hey everybody, another one of these evaluate problems where this very last factor would be too much trouble to multiply by hand. This factor at the end, 2 to the 16th plus 1, is certainly a very large number. These numbers are believable, like this is what, 257 here maybe? Not too big a number, and this is 17. But once you get to 2 to the 16th plus 1, that's way too much trouble. We don't want to spend our time waste away our lives multiplying out something like that, even though it's doable. Now, what we're going to do is, this 3 looks kind of awkward, but notice that, and this looks very strange, but you can represent 3 as 2 minus 1 times 2 plus 3. 2 plus 1, excuse me. Okay, 2 minus 1 is 1 and 2 plus 1 is 3. 1 times 3 is 3 last time I checked. All right, but notice this is equal to 2 squared minus 1 squared. So you see, in a strange sort of way, we're using the difference of 2 squares result, the very well-known result that says if you have a plus b, the binomial a plus b, times the binomial a minus b, the middle terms cancel out. You get a plus ab and a minus ab. They cancel, and so this perhaps is the most popular identity in all of mathematics. That's equal to a squared minus b squared. It has an interesting geometric interpretation on a square too. Okay, so it's a squared minus b squared. Now let's take a look at how this problem might carry on. And I've written down most of the work here. Everything we just discovered is written down here, and we just repeatedly use this difference of 2 squares formula. Let me get that erased and neaten up just a little bit. That's minus b squared. Okay, and again, I've just rewritten the original problem with this observation, this kind of obscure looking thing that relates 3 to the structure of the rest of things. And you just continue to use the difference of 2 squares formula, okay? Notice right here we get the 2 squared minus 1, but when you multiply that against this next factor, we get 2 to the 4th minus 1. All right, and then you see how we're just repeatedly using the difference of 2 squares. 2 to the 4th minus 1 times 2 to the 4th plus 1 is 2 to the 8th minus 1. All right, and then right here, this would be equal to, let's just finish it off here, 2 to the 16th. You end up with 2 to the 16th minus 1. Times 2 to the 16th plus 1. I still think this is relatively amazing how you can do stuff like this without having to use a calculator. Just algebra. That's plus 1. And again, what we end up with right here, due to the difference of 2 squares formula, this would be equal to 2 to the 32nd. 2 times 2 to the 16th times 2 to the 16th, you add your exponents, you have 16 copies of twice. Okay, so you have 2 to the 32nd minus 1 plus 1. This 1 that was dangling around right out here is the same as this. That's equal to 2 to the 32nd. Now, some people may debate whether or not evaluate is the correct instructions here, but 2 to the 32nd is just some number, right? Now, if you think evaluate means to write down the Hindu Arabic expansion, then we didn't evaluate. But we did get an answer, a nice clean answer. 2 to the 32nd is the solution to this problem. Let's write it down up here. Thank you for viewing.